Yeah, good morning. Thanks for having me. Um, I'm Anton. I'm a Google developer expert for Flutter and Dart, and I'm working at Heartbeat AI, bringing our customers the cleanest and cheapest energy. So, design systems. Albert already touched upon this slightly. Why do we need a design system in the agentic-driven era? Why can't we just go to our favorite agent and tell it, build me an energy product, and then to cover the design part, we just say, make it pretty. Well, this may work for like small side projects, like on an enterprise scale, this will fail because good design is more than just being pretty. It's about being consistent for the user across the whole user journey. It's about having a good relationship within your teams between the designers and your development. And through all of this, good design actually helps building trust in your product, and trust in your product is super, super important. And obviously, this whole issue was a challenge to be tackled already way before agents. And so roughly 2.5 years ago, we at 1KOMMA5, we decided to build our harmonized design system. And so we built this as a problem and a solution to a problem between human to humans, between our design team and our dev team. And so what were the challenges was to have a good design system, and we wanted to make sure that it feels good for designers to use, but also for devs to use. And so we decided on a structure that was driven by our designers, and we settled on what's called an atomic design system. So we have our atoms defined for like our colors, our spacing, typography, building out molecules, our buttons, controls, progress indicators, and so on, all the way to organisms, more complex elements. And all of these form then our products. And so then we had this structure and we wanted to have collaboration between design and developers. And collaboration really is all about communication. And communication starts, in my opinion, oftentimes with just speaking the same language. And so this is what we wanted to achieve, is that we speak the same language in design and in development. So we wanted to have one-to-one parity between design and the respective implementations. Starting with these atoms and the tokens, they start out in Figma. And designers may use them to select padding, to select a color, to select typography. And to then bring them into Flutter, we wanted to have one-to-one parity. So what we did was we created a workflow that generates out of these Figma tokens that we export, generates context extensions and theme extensions that developers can use them with the exact same naming. So when you use a padding token, you have the same token name, the same path. It's just that in Figma, you have slash-based paths, and then in code, you have dot-based paths. And so this was the parity between atoms and tokens. And from there, we took this towards the rest of the design system, to our components as well. So our tag component and designers can adjust things like the size and what type it is, the icon or the label. And then on the Flutter side, we did the custom implementation route. We basically built the same way, and everything is named the same thing. So if we want to change the size, then the parameter is called the same and the options are the same. And so we did this across the whole component catalog. And this really sped up things quite a lot, because you could just look at something in Figma and just apply the same naming. And so as you saw on the first slide, Widgetbook is somehow involved. So how does that actually involve Widgetbook, and how did that come into play? So the first thing was that we built Widgetbook Harmonized, which is our widgetbook for our design system. And this allowed us, during the implementation of the design system, to build and catalog our widgetbooks, our components in isolation, to then have them in Widgetbook for future reference. And once again, speaking about parity between code and design, we basically have the Figma panel here on the left with all of the components from the Figma design system. And then in Widgetbook, each component has its own entry. So one-to-one parity, and going further, even on the component level. So once again, that's the panel for a designer to adjust the tag component. And when you look at the implementation of the tag component in the Widgetbook, you have the same things with the same names and the same options to adjust. And so this was our design system. We had that in Harmonized, and we realized, hey, this building stuff in isolation is quite cool. Let's also just do that for our app. So we also built Widgetbook Heartbeat, which basically is a widget book where we catalog and have the ability to build in isolation each screen and each section of our apps. So this, for example, is our live view, where people can see what their house system is doing at the point in time. And recently, a colleague re-implemented parts of that. And he said Widgetbook has been super helpful building this, because it's a lot easier to have like different asset combinations, for example, or determining whether the battery is currently charging or discharging, just via configuration options in Widgetbook and seeing them in action right away. And this was then our workflow. So basically we had designers handing it over to implementation, then the devs creating a PR, it gets reviewed, and then after merging it gets into QA. But as I said, collaboration is about communication. And we noticed that basically after the handover, there was quite a long gap until the designer actually communicated with the developer again. So we made use of Widgetbook Cloud to have a design review in that process again. So now we have in parallel, while devs review the code, have designers visually review the changes in Widgetbook. And this has a lot of benefits, because now devs, when they review code, they don't have to worry about how that looks anymore, because the designer can take care of that. And the same way in the QA phase, and we will get more about testing later today, QAs also don't have to check how if everything looks correct and to spec, because the designer reviewed that. And since we've introduced this workflow, we actually never shipped a visual bug in our app. In practice, this looks like this then. So basically we have our dev review seeing, okay, somebody changed a metric from a slim metric to a minimal metric. Code change looks good. And the designer would see, okay, this is the visual change and how that changed. And this is quite cool. And as I said, we did not ship any visual bugs since we had this, this workflow. And then the last piece to the puzzle to design system adoption in our org was to actually make people adopt it, because a design system is only useful if it's actually being used. And for that, we had two steps, basically. First step was just documentation and training our devs to, basically, we had like this big Notion document, building Flutter apps with Harmonized, to educate people on, okay, these are the patterns we want to follow. These are maybe some pitfalls or details to look out for. And then the other thing was lint rules. I know that our friends from Lean Code, they have a solution for that as well, is to basically tell developers, especially coming new into the project, hey, elevated button, please don't use the elevated button, please use the harmonized primary button for this. So this was how we did the design system for human-to-human interactions. So how do then the agents come into the mix? And so when we started this process, we just took our agents MD and put a line in use components from Harmonized design system when building UI, and then also address all analyzer and lint warnings. And that already took us quite far, especially because of the analyzer and lint warnings, because as I showed on the previous slide, we had this warning that basically we had a lot of components where we said, okay, yes, don't use this material thing, just use this component from Harmonized directly. And that was already great. And then we took it a step further by introducing some skills and sub-agents. So we basically created a build with Harmonized skill, where we took a lot of the documentation we had in our Notion page to put into a skill for agents to pick up on. And once again, it just says basically to use the components, pointed towards that each component has documentation for it to read, to use the correct tokens. And then that was good. And then we realized there's still a bit of a gap when we bring in, using the Figma MCP, some designs from Figma directly. So we created a sub-agent that basically, when it gets a Figma link, automatically converts that to use the correct tokens and the correct components. And that's been working so great that basically now in practice, we can just say implement the screen and pass in a Figma design link. The agent will then start using the sub-agent to translate that design into Harmonized. It will build the screen. We told it to add that screen to Widgetbook so that in like the review phase, we still get this visual review to see what happened. And then basically the agent tells us it's done. And if we now look at this, it looks awfully similar to this, what I showed at the beginning. That with the correct baselines and a design system, make it pretty actually kind of works. And I think what this shows is that strong foundations like design systems are crucial when building with agents. Because they help the agent to actually do the right thing that you are expecting it to do. And another big thing with agents is obviously closing the agentic loop. And to show you a bit what Widgetbook can help you with that, I'm happy to hand it over to Lucas now.
Sehr gut, Anton. Yeah, welcome also from me. Thanks a lot, Anton. Anton's talk really speaks for itself. It explained really well how you can use Widgetbook to, first of all, build your widgets in isolation, how you can then catalog your widgets and compose them to your own custom design system, like the one that Heartbeat has been building. And then you can test and review your widgets to make sure that you always maintain a great quality level for your UI. I now like to add to what Anton said with what we've been recently building at Widgetbook. And we are now releasing a workflow that helps you to teach your coding agent to actually judge its Flutter UI before a human has to review it. The workflow looks as follows. We first of all start with the foundation. It's very similar to what Anton already showed. So we're going to have a Widgetbook skill, and that Widgetbook skill really makes sure that your design system is being used consistently. Afterwards, you're going to have a local feedback loop for your LLM that makes sure that your UI already has a great quality, and only then the human gets in the loop, and only then the human reviews what the agent built very easily using Widgetbook Cloud. How this looks in detail, as I mentioned, quite similar to what Anton already showed. It's a Widgetbook skill that basically understands your design system and ensures that your agent is using your design system consistently. Afterwards, we are now able, with Widgetbook v4, to combine Widgetbook and Flutter test. And that allows you to combine Widgetbook and therefore your design system setup with all sorts of UI tests. So golden tests, widget tests, interaction tests, you name it. And by using golden tests, you are then able to get a screenshot from your Flutter implementation in Widgetbook, and you can then compare it to the Figma screenshot by using the Figma MCP. So if you're using the Figma MCP, you are able to get a screenshot from your Figma design, and you also are able to pull the Figma tokens, and you can then compare that Figma screenshot to the Flutter screenshot, and you can also compare your Figma tokens to the Flutter properties, and that gives the agent the chance to iterate until it matches. Usually, if you're now using, in the end, whatever models, we notice that most of our customers are using Claude Code, and if you're using the highest models there, very often it's already a one-shot. But if it's not a one-shot, this really helps you to get another iteration in until it really matches. Then, as I mentioned, you can combine Widgetbook with all sorts of Flutter tests. It's not only limited to those basic UI tests, but you can also extend it with accessibility tests. You can, for example, also use the meets guidelines tests that already cover basic accessibility needs for you. And that, in the end, allows the agent to really fix itself before the human gets in the loop. And therefore, the agent then really creates a high-quality pull request for you, and only then the developer gets in the loop to review it. As Anton already mentioned, first of all, you would have a code review in your favorite Git provider, and you would then have the visual review on Widgetbook Cloud. With Widgetbook v4, we are now not only able to analyze screenshots, but we are also able to analyze both your widget and also your semantics tree. And that gives us a lot of power, especially for accessibility testing. we are working together with many leading European enterprises, and we are very much aware that many of those enterprises did a tremendous job over the past year of getting their app to an accessible state. But most of those companies also noticed, while they were accessible or close to being fully accessible at some point, over time they lose more and more of their accessibility quality. And with Widgetbook, we now shipped accessibility regression tests that helps you exactly with that. Very similar to how visual regressions work, where you're basically spotting all the visual changes in your app and can basically judge, are these changes actually intentional? That's what we are now introducing with accessibility regression testing for the accessibility side. So we are automatically catching all your accessibility changes, and you can then easily judge if those accessibility changes should actually be shipped or not. We're extending that with a rule judge that we're bringing to Widgetbook Cloud, where we also catch WCAG violations for you and show them to you also in your pull request. And we're also currently already testing with our first customers an AI intent judge that we're bringing to Widgetbook Cloud. So many of our customers, if you ask them what is the #1 reason why accessibility testing is not consistently done in your app, is because of screen reader testing. That is very cumbersome to do, takes a lot of time. It's often being pushed to QA, but QA also has different responsibilities. So very often this really lacks. And with Widgetbook v4, we released a documentation feature that allows either you as a human or your agent to really document the intent of a widget. So how should the widget be used? What is this widget for? And our intent judge in the cloud can then judge if this design intent actually matches your semantics tree, yes or no, and therefore gives you already a great indication not only are your semantics being used consistently, but do they actually make sense? As a recap, with Widgetbook Cloud and Widgetbook v4 is our open source package, we help you primarily to prevent design system violations. So we ensure your design system is being used consistently. We then offer a local loop that allows you to have a great quality PR of your agent, and only then you as a human get in the loop, but you can then very easily review what your agent has been building. If you have any questions about this, please feel free to talk to Anton and me at this conference. In the other room, I'm also going to have a small Widgetbook booth where you can ask all of your questions. Anton and me will also participate in the design system panel, so happy to answer your questions there as well. And for everyone that is watching us online, please feel free to reach out to us on social media or the email you're seeing on the slide. Thank you very much.